Welcome back, my pupils. This is Gene coming to you with Reloading from the Hot Pot. Today we are at STONER CNC and we are going to take a tour of the shop with the owner, Matt. So let's go in here and meet him.
Hey Gene, funny seeing you here.
Hey, look who's here. It's Matt Stoner, the owner of STONER CNC. All right, Matt. How are you doing today?
Good, good. We had fun at the shoot today and thought we'd swing by the shop and got a few different products out here that we do.
Yeah, I'm very interested to see what you do.
We're mostly known for our pistol grips, but we're really a full-blown machine shop. We originally started out the business doing knife handles with some of my first products. And these are actually a new product that we'll be releasing for the Benchmade Adamas. But we started out the business with knife products and then quickly moved into different pistol products. We have some 1911s, some Beretta compacts, Beretta full size, some Rugers, more Berettas. In the early days we did some cell phone cases. Those were for, we have a Samsung S5, another Samsung S7 maybe, and I believe that's an old iPhone 5 case. Cell phone stuff didn't really work out because the Chinese got into that one, so started just going back to the basics of knives and guns. We recently got a water jet, and that thing's pretty cool. We'll do a demo cut today, but it'll cut basically anything. Cut rock, steel, stone, G10, anything.
Do you know what we call that here in Ohio? We call that OH10 because we live here and we love it.
That's right. So we got some new products. We'll do a demo on a 5th axis part that we've been working on, 223 comp, and will eventually come out for 9mm, 6.5mm, and 308s.
So you're going to have these compensators available soon?
I think it's probably a month or two. They got to go to nitriding, get a left-hand nut instead of the crush washers, so a little bit more development, but we'll run a demo and they're actually really functional.
Now they look really neat and they're very innovative, and I had the opportunity today to see one in function under fire, and it was amazing. 80% recoil reduction.
Yep. So those will be coming out soon. So just some other random parts, hydraulic fittings, cut out on the water jets.
What is this here?
That was just a prototype steel knife, just a cram bit that we did for a guy. That design didn't actually go into production. They've got like thinner rings and different stuff. It's also how to plug into my buddy Gary at Creeley Knives. Every now and then we make some different magazines and stuff. Should collect more magazines, but Gary's got an excellent knife. And then some of the guys ask, like, you know, where did you learn how to machine? Well, my dad's been doing motorcycle engines for decades. So everything on that engine would have been machined. So that's kind of where I learned how to machine. Just doing stuff like that when we were kids.
Very interesting. So you have a family history of machining.
Yeah, my dad's been a machinist his whole life, and then he would have taught me starting out, and then I've been doing it about 15 years. My dad, I would say, is actually better at some of the old school stuff, but as the technology progresses, I don't know, it's just a little bit different. I've got different skill sets than what he would have. He's got different skill sets than what I would have.
Well, different methods, but the same end results.
Yeah. Well, come on in, I'll show you the, we'll go take a look at the machine that's going to be making these compensators, and we'll run apart.
Yeah, that machine is really cool.
Yep. Show you the servo door. If you want some shorts here, it'll do some other cool stuff. This is a 5-axis machine, so the table itself will twist and tilt up and down. Where to stop it there. So the machine would move X, Y, Z, and A and C axis. You got 5 axes there. So push the button there. It's clamped, and that's Japanese machine. Really high speed. So put the camera in there. I'll show you the tool change and how fast that is. If you can. So it's about 1 second. And that's my slowest tool change. We got the 10,000 RPM. We'll show you the through spindle coolant on the gun drill. T5. There we go. Throw the door in auto and she'll just go. That's where you'd probably edit the sound out. The gun drill coming up here will be quiet. Here it indexed 90 degrees. It's utilizing the tilting axis. Then it's also utilizing the C-axis. It's doing your wrench flats, 4 of your wrench flats right now. Here in a second, we'll come in and do the spot drill, pilot drill, gun drill, and then drill out the inside for the threads. There's the gun drill. It's just blowing coolant straight out the top of that comp.
This is a very messy process.
Well, it's a good thing the machine's enclosed. Try to keep the mess inside. But that was a tool change there, about 2 seconds, chip to chip there. That's the thread mill there.
It's a very cool process. About how long is it going to take total to finish this piece?
I think these are running right around 18, 19 minutes. It'll do a little bit on the cycle time yet, but it's kicking out functional parts. A little bit of tumbling and some black nitride. They'll be good.
This is a really cool product, very innovative.
I think
something they have come up with now, and I seen it operate today, and I was very impressed with it.
I think we're the only guys on the market with a radial cut port like that. It's the hard way to cut it. All the other ones are going in like flat, or some of them at like an angle, but not like an angle and a rotary.
Yeah, this actually has like a cup feature to actually direct the blast in a specific direction instead of just moving it away.
It gets you more surface area too, so 85% recoil reductions on a 223.
Which is incredible.
Yeah, it varies a little bit on the bullet and the weight of the rifle and so on and so on, but industry-leading comps be coming to the market.
The industry-leading comps from Stoner CNC. I'm very impressed and very looking forward to trying a couple out.
So we'll eventually put it on a robot. My buddy at AI Automations did the programming on this. We'll run a batch of probably 200 to 500 of them, and then once we get the tool life and all that figured out, the robot can man the machine and have production 24 hours a day is the goal.
And he has a doggy in-house, so there's treats for the puppy. Over here, we're going to check out the water jet system that he has. Could you explain a little bit about the water jet system and the amount of PSI that this requires to do it?
Yeah, it's 50,000 PSI, 30 horsepower pump. So most people think it's cutting with water. It's actually cutting with sand. Fit a little bit of sand over here. The water is just the medium, and the sand's called garnet. It's real super heavy, very, very hard. So we cut through almost anything on the planet except for diamonds, a couple ceramics, and a few gemstones, basically. But
very, very neat, and it's actually very heavy compared to sand.
So the water jets are a little bit more maintenance intensive. So there we got a slat. Everything's sacrificial to some degree. That if you cut enough stuff, you cut through your table. So we had a new table up on in there, and I guess we'd be ready to fire it up.
And just in case you wondered, this sign is for real.
Most people think we just do knives and gun parts. Today we're cutting some motorcycle sprockets for one of my dad's old antique bikes. Water jet programming is real super easy. That's 1/4 inch mild steel. But if we were cutting G10, we'd just select another setting. If we were doing brass or copper, yet another setting. Tool steels, plastics, stone, wood, foams. The machine will basically cut anything, but mild steel is what we're doing. So, just calculating that, I'm gonna index it to tome. We're gonna start in the corner here. I'm gonna flip my muffler down, raise the water, and begin machining. Might splash a little bit. It could go. I've been wet before in my life. It's okay. That's it. Cutting with water and sand, and in about 10 minutes we'll have a motorcycle sprocket.
You know, I never knew through water jet that actually used sand for the medium.
Yeah.
And the water is just the carrier.
Yes.
That's all it is.
Sand does all the work and the cutting, and the water, I don't know, the water's the medium, like what you say.
Yeah. It's just the carrier. It's all it is.
It's simple and it's elegant, and it literally cut almost anything in the world.
Very neat. This is such a cool shop, people. This is really a privilege for me to be in here doing this.
Yeah, these are skip tooth motorcycle sprocket for early 1900s motorcycles. They don't make that chain or that sprocket anymore, so if you've got an old motorcycle and need a part, this is how you got to make the part.
You got to come up with it somehow. Fabrication is today's technology.
Yep. Let me close the door. This will take a minute to boot up.
I've got home PCs, I know.
These are expensive on
When I bought my first PC in 1998, I spent $1,200 on it.
Okay.
And it was a refurbished office unit. Gateway.
Yeah. That one there's 5,500. Run the CAD CAM stuff. Yeah. Give me a second. Need to start filming.
She's rolling now. I'll just edit
okay.
it. I love editing programs.
See, where's that?
Take out all the ums and does and blah, blah, blah. What did I say? I don't know what I was saying.
Okay, so this is optical CMM. So we're doing aftermarket knife for pistol handles, or just wanting to verify any type of work that we might be doing. We use this thing. If it can see it, it can measure it. There's the cutting edge If we wanted to reverse engineer this knife, say for aftermarket handles, we could do so.
And you do make aftermarket handles for these knives?
These are a new product that we'll be releasing. We've done some Beckers, and this will be our first Benchmade. I'd like to get into some Spydercos, a couple of the tops. There'd be a host of knives that would be suitable for aftermarket handles. The Benchmade Adamas doesn't come with handles, although it's an excellent knife. I think we had an opportunity there.
Nice.
We'll scan that. So there it's just indexing around the blade there. We can see the jimping on the computer screen. And in a few minutes it will give us a result down to the nearest, I guess, 5th decimal place for accuracy, which...
That's very tight.
I don't even know how you can't even see that.
No.
It's like a speck of dust.
This would definitely be something to be had to reverse engineer everything that you would need it to do.
Yeah. They were alarmed out because I didn't have the blade back far enough. I was trying to go around the tip, but it ran out of room. That's okay. I'll show you one of the like pennies and loose change are kind of fun to look at. It's got a joystick, kind of like an Xbox.
Makes it easier to control the eye.
Yeah, you just need to be able to move a joystick and you can operate the machine to some level. Yes, there's a penny. Get that autofocus, and we could go way in if we wanted. Might go a little bit out of focus, but that's okay. If we can see it, we should be able to measure it. Let's try a 3-point circle. So the inside of that penny is 11 thou in diameter, which is just insane. It's measuring all this stuff this accurately using cameras. But it's essentially like a little mini CNC mill with a digital camera attached. So that's how stuff gets reverse engineered for aftermarket products and done correctly.
That is very interesting. I've always wondered about how some things like this are done, and using this camera system and you know, programs that you have. Now I know.
Yeah.
Very interesting.
It's cool, like, just to horse around with it. You can throw like a piece of bologna on there, or like you can see the fat cells. It's ridiculous. At like 400 or 500x magnification. So
you quit eating bologna now since you've done that?
Yeah.
Just saying.
Yeah, blades of grass.
Don't put a hot dog on there.
Leaves, all sorts of things. It's neat to look at from like a nature perspective.
Yeah, and actually see things broken down to their elements.
Yes.
Yeah.
Yes.
Very, very interesting.
You guys want to see the CAD cam? I'll show you the CAD cam on
I'm about to show you how this innovative crush washer, or, well, crush washer adjustment is for these muzzle brakes.
So we used a left-hand thread. It doesn't thread on like a regular compensator. The advantage of that is you don't have like a traditional crush washer, but instead of jam nut, thread your comp onto the barrel, and then you back that jam nut out, and then you can position the compensator anywhere you want on the barrel for alignment with just 2 wrenches.
That's very innovative, and I think it's amazing. Like I said, I got to see one of these work today, and it was absolutely amazing.
We'd started the design with, well, 3D prototypes, and then a number of just actually crudely made compensators on Bridgeport CNC mills, but for production we decided to go with 5-axis Brother. I could show you a little bit of the machine simulation on what was filmed downstairs. So in the 5-axis, you need accurate work holding, accurate representation of your stock and your tool holder so you don't run into collisions. So the first step would be decking off the top face, milling a shoulder. We're milling the wrench flats there, and I'll show you on the 5-axis. On the 5-axis stuff, you better have your head wrapped around straight because there's about a 1/16 of an inch clearance. So we're about a 1/16 of an inch away from colliding with the machine. But the machine simulator comes out right, the actual machine comes out right. So clearance is what they say.
So some just time and paying attention to things.
Yeah, just very, very detailed on the rendering to safely run the machine. So the last thing we want is a crash on that. So there's the drilling process, and there's the gun drill, the big drill, the thread milling, the outer thread milling, and I suppose that's about as much as I'd want to show. We could look at some 5-axis. I'll skip ahead a little. The ports are actually done with a macro program, so that won't fully render. It's macro programming with different variables to efficiently cut out that shape. I suppose that's why nobody else has done it. The programming is this next level, and the macro programming is the upper echelon of CNC milling. That's how they're cut out.
And your company is doing this and has figured out how to do it.
I wouldn't say that.
What would you say about that?
My brother is a talented engineer at Honda. That's what he does for a living.
Okay, so with some combined minds,
yes,
this process is innovative and has come up to you.
We're able to do what we thought was impossible because the CAD software doesn't support that cutting mechanism. The brother CNC wasn't happy with it either. You got to get into the parameters and start adjusting some stuff that's very deep into the weeds.
Very interesting. So for innovation in this field, STONER CNC.
I'll just
you moved
back that all the way out. So I use Gibbs Cam for the programming, and it's actually a project for my dad. So he drew the sprocket. I imported it into Gibbs Cam. We laid 3 of those out on a sheet of 1/4-inch steel. We would import that into the OMAX. Quality, in this case, we're doing quality 5. We don't want any slop on that chain. We want a precise fit, so we're going with the highest quality cut we can on the outside. And on the inside, we're going with a Q3. So there it's changing the colors. I don't know if that comes up in your video.
Oh, it's coming in fine.
It's just color coordinated. So you had a Q5 is the blue, and the Q3 is the pink. And then water jet programming is super easy. Auto path. One button gets most of the programming, unless it's very, very elaborate where you have to manually program it. But the ease and simplicity of running a water jet's never been easier. And one button that's pathed, and we're cutting the parts.
America, baby. I'm going to go back down here and check out the water jet. He was showing me the CAD CAM programs. We want to see how the progression of this water jet and these sprockets are going.
Yeah, it's got a minute 26. If I lower the water, it's going to get loud, but we'll be able to see it cut.
Okay.
We can, it's going to get real loud. Normally you'd always cut submerged so you don't get the splashing, but there we're cutting above water. See what we got there.
There you go. Good part. And that is a sprocket that is obsolete until now. quiet while it's underwater.
Yeah, but very
That
loud.
is-
I'm going to grab a can of WD-40 and we'll spray it so it doesn't rust.
All right. Very, very interesting.
There you go. WD-40 is water dispersing repellent recipe number 40.
Yes, it is.
That's what it's made for. So, yeah, we'll have 3 more of them and it's done.
The machine is done. We have 3 brand new, used to be obsolete sprockets that are now available for these antique motorcycles.
Thing until the mid-90s. It depends when you were racing.
Yes, that's when I was racing, was back in the mid-90s, and I was sponsored by a FAM Sprockets.
Really?
Yes. And a fan, and I always talked to my rep and stuff, and he said, well, these are all done on machines and they're precision, but I never actually got to see them made.
Yeah.
I discussed it with him.
Water jets are probably not the way they're doing production sprockets, but on low volume one-offs, absolutely. That's one of the areas the water jets shine. They'll cut anything. So if we're making some rare sprockets or just tooling for the shop, or that robot thing that held all those compensators,
Yeah.
we're cutting our own tooling on the water jet for other machines in the shop and vice versa.
So this is a very handy piece of equipment to have.
Yeah, you could never justify like financially buying one, but after you live with one and see all the intangibles that it brings, I don't know how shops get by without one.
Very interesting.
Yeah, I'll show you the, we should go check out the 5-axis, that should be done.
right.
And
Well, let's go take a look at that.
it's done, the machine's done, it opened the door for us. I'm gonna blow off the part, and there she's done. Fresh out of the mill.
All I have to do is lop off that end.
Lop off the end, drop it in another machine, and then we'll crown the barrel, and that's about it. Nitride it, put a logo on it, drop it in a box. This was that tooling plate that we cut in the water jet, so you got one machine making parts for another machine. But
Almost kind of AI in a way.
yeah, like
A simple form of AI.
like a Berserker clone or something.
Machines making machines and parts for machines.
Yep, you got it. Once you get enough machines, you can make about anything.
This here is all the G10 material that he does carry in-house, one rack of it.
Yeah,
But
yeah.
let's hear a little information about G10 material from the boss man.
It's about as strong as like aluminum, more durable, a little bit heavier than carbon fiber. And it comes in different colors. This is a orange-black layering. That'd be a 2x2 layering, standard layering. They have lots of different colors, from like artificial ivory-looking stuff to just regular earth brown. They'll do like a Ferrari red. This is Taro Tough, similar to my Cardra, but with like brighter coloring. They do G10 with different linings. It's probably got about 3 or 4 layers of the white, 2 of the blue, 2 of the white, 2 of the blue. They can layer that any which way they want to create different effects. Let's go ahead and show you a 3x3. That's our Arctic camo. It's a 2x2x2, so it's black, gray, and white, and then it just repeats. You can see that maybe a little bit better on like a mil-spec camo. It's got 3 layers that are sandwiched. They've got a green, a tan, and a black. And depending on which way you run the grip, you can create different effects. One way it looks more like a military camo, and the other way it looks more of a desert camo, just based on which way the product was ran.
Very interesting. You know, I knew they did this in layers, but I've never seen it like this. as far as in the sheet form itself before it's milled.
Yeah, once you get into volume production, the only way to do it's large sheets. Typically you get about 50 grips, would be like just a standard number, 50, 19, 11 grips out of one of these sheets.
That's a lot of grips.
On knives, it can vary greatly. From small knife, you might get up to, say, about 100 is usually the upper range. And then on great big machetes, as low as maybe 25 for something that's about as big as like a sword.
And as far as G10 goes, Stoner CNC has you covered. This is another rack that is just full of different colors, layers, almost anything you could possibly want for your G10 needs. And they do offer some custom services, semi-custom services, and standard production.
Check out these Burled G10s. It's camo infused, and they got all the different colors, and they just come out wild. Each one's unique. The blue is probably one of my favorites.
That is beautiful.
We do those for a custom knife maker that's once a unique offering.
Now, is that what my grips were made from?
Yours were the blue-black 2x2.
Blue-black 2x2?
Yours was more of a standard layering.
Okay. I really like them. They were very comfortable and they looked very nice on my firearm.
They came out good and they matched the mag well and give that Rock Island a little bit more flair.
Oh, absolutely. And I thank you very much, Matt, for doing this for me. Could you explain this a little bit? Because this is quite an odd looking machine here.
This is a tool setter. If you come around here, we've got our test piece in there. It should be exactly 3 inches, and I'm going to say exactly 3 inches. That 5th decimal place I'm not going to worry about. But on a CNC, this would be how the tools are measured. You just come in. Well, a carpenter might care about the 1/16 of an inch. We go out to the 4th decimal place.
Which is how big? 4th decimal?
A human hair is at the 3rd, 20 times finer than a human hair.
20 times finer than a human hair. These tools have to be measured to do precision CNC work.
So we have big mills and little mills. Everybody always thinks bigger is better, but the big tool costs 3 times as much to run as the small tool. So I like my small mills. So people think we do, knives and pistols, but really what we're into is small part production. I like doing parts that fit in your hands, so the shipping's not bad. You get those out to a lot more people, and you don't need big, massive equipment in a huge factory. So we like the little tools and the little parts.
So it's not just on major contracts, but you also work for the common man as well when they need something.
Yeah, the eBay, Amazon, we're doing one-offs for a lot of the customers. And we've got a number of pistol smiths, knife makers, and even some people in some different industries that we'll do stuff for. Our specialty would be in the G10 and the micartas and the FR4s and certain types of composites. That's what we're good at, whether it's a knife part or an electrical part.
This is very interesting. Very privileged tour of this very unique machine shop.
That's a compression tool. Tap's actually on a spring. If you're doing real fine tap work, or actually where they have application is where your plate's going to flex. These machines have got synchronous tapping, so you can tap at 6,000 RPM. But if your material's not like solid and it flexes, you need a floating tap holder, and that's what that is. A little bit of a specialty tool. The hydraulic tool holders are like a thing nowadays. They're just loosen and tighten with a set screw, and they've got hydraulic oil in there. I have no idea how they make these things, but they've got hydraulic dampening then, so it's kind of like a shock absorber on your car when you're running hydraulic clamping. We don't have a tool in that one, but that's what we're using on like the gun drill. That you've got the dampening, you've got high precision, and you've got the ability to pass coolant all the way through the tool. So these are the 6 spindle drill presses. They're Chaz Allen's. It's kind of an interesting history on these. Chaz Allen made such good drill presses that this one's over 100 years old. So this would have been the modern, well, 100 years ago, this would have been the modern day CNC equivalent. They would have had a team of guys drilling holes down here, drilling holes. This would have just been maybe a two-guy job to keep this machine running. They didn't have CNCs, but in the day this would have cost as much as a CNC. The problem with Chaz Allen is they made such good drill presses that ones that are 100 years old still run. We don't use it as much as what we used to because we have CNCs, but if you just need to ream a hole or do some quick drilling, these things are perfect, and they're dead solid too. Like a modern day craftsman would have a little bit of spindle flex on that if you pulled it down. These things are just solid and like cast iron. Sorry, I just thought that was kind of a cool iteration that you've got a 100-year-old drilling and tapping center, and over here you've got modern day stuff, but they're both in the same factory.
It's amazing to see the progression of equipment that does the same job, just with manpower to automation.
And the speed's incredible too, that we've seen those things drill. They're drilling at twice the speed of gravity, whereas these are hand-powered.
Yeah.
We've got 16,000 RPM over there, and I don't know, these things cap out maybe at 1,200. The speed went up 10 times on the RPM and 50 times on the drilling speed.
Technology is a wonderful thing, but it is very, very nice to be able to see something that's 100-year-old where the CNC machines come from. So this is its daddy.
Yeah. We still use them for
the CNC machine's daddy.
Odd stuff. If you need to make a quick hole or ream something, or maybe you pulled something off the water jet and want a reamed hole on that, bring it over here.
Very interesting. Well, Matt, it's been a pleasure meeting you. It was really nice shooting with you today at Northwest Ohio Combat Pistol Club. This has been a wonderful tour, and I'm definitely going to need some more G10 products in my life.
Okay.
I can see this now.
Well, you'll have to let me know when you're up to Wassian next time, and we'll go shoot some pistols again.
All right, that sounds great. Thank you very much again for it. Everybody out here on my channel, on my pupils, check out Stoner CNC for all of your G10 needs, and they do production work and some custom work if it's interesting enough. So bring on your ideas. Thank you very much. And always remember to what?
Subscribe.
Keep blowing the smoke.
Keep blowing the smoke.
There we go. Thank you, everybody.